Now we will move forward. We will move forward to what? We will move forward to the next part of it. Next part of it means we will move forward to next part of it. Next part of it means now we had seen that we had seen so many experiments of light. Experiments of light. Please understand it again. Slowly we are moving to the Bohr's theory. Today also we cannot move. Where we have to know these basic concepts. Experiments of light. Whenever I am using the term light now, whenever I am using the term light, you should not think it as the visible light only. It can be any electromagnetic radiation. It can be any electromagnetic radiation. In that case only, I am using the term light. Okay? We have seen different applications of light. The most common applications, the most common characteristics of light you already know. I am just writing them. It is reflection, refraction. This is all you know, that is why I am writing. Reflection, refraction, these two terms at least you know. These two terms, these two particular experiments of light. Light means electromagnetic radiation. It can be any electromagnetic radiation. Again I am saying, it is not necessary that it has to be visible light. Okay? These two phenomena of electromagnetic radiation can be very nicely explained by considering the electromagnetic radiation as the continuous wave. As the continuous wave which we talked in the beginning. That is electromagnetic radiation concept. That reflection, refraction, like that so many other incidences also, interference, diffraction, okay, which you might not be knowing, slowly we will learn in physics, okay, interference, diffraction. These are all explained by considering the electromagnetic radiation as the wave, continuous wave, okay. And this particular theory, as you know, is called classical theory, But there are so many other experiments, are there which are not explained, which cannot be explained by considering the electromagnetic radiation as the constant wave. For example, the photoelectric effect. This we are going to study in detail. Photoelectric effect. This is the only one which I am going to study in detail. Photoelectric effect. Okay, but I am telling the name of some. Black body radiation, black body radiation, then Compton effect, okay. These are different experiments, which could not be different experiments of electromagnetic radiation or different experiments of light, which could not be explained by considering the electromagnetic radiation or considering the electromagnetic radiation as, or the light as the continuous wave. So, how this phenomenon are happening? The theory needed the modification. Again I am saying the same thing now. The theory needed the modification. The modification was done by a scientist first called Planck. I don't know whether you have heard the name or not. If you didn't hear, it's fine, absolutely fine. Planck. What he told? No, electromagnetic radiations are not continuous waves. They are not continuous waves. They are particles. He told they are particles. Suppose this is a source of electromagnetic wave. This is a source of electromagnetic wave. Suppose this light, any bulb, any this thing, any LED, whatever. From that the light is coming. In the classical theory, according to classical theory, it was considered that the light is coming like this, a constant continuous wave. Light is coming like this. But what Planck told, no, the light is not coming like this. No electromagnetic radiation is coming like this. They are coming like packets. Just a packet of light, another packet of light, another packet of light, another packet of light. Just a packets they are coming. Constantly the packets are coming, one after another. For example, I am just giving a different example so that you can understand that. All of you nowadays have seen that the bowling machine, right? The cricketers are practicing, or the table tennis also. You can see that the bowling machine are there. From where one after another, the balls are coming out, right? Just like that, they told, or he told rather, Planck told, that the electromagnetic radiation is not coming out as a continuous wave. It is coming out as what? It is coming out as the particles or packets. It is coming out packets of energy. Packets of energy. Each packet of energy he called photon. Each packet of energy he called photon. Okay, so they are coming out as photons. Now tell me, suppose, I know that everybody knows it, everybody loves cricket, so I'm just telling it in the term of cricket, just for your understanding. Suppose Virat Kohli is batting. Okay, Virat is batting and practicing his batting, and another bowler, suppose Bumrah is practicing his batting, and through the bowling machine, the balls are coming out for Virat and balls are also coming out from in the two different nets, two side by side nets. They are practicing. Obviously, the speed means I am talking of the speed of the ball that is coming out. Suppose the speed of the ball is also same, but the frequency means in 1 minute Virat can play how many balls? Obviously, the same number of ball cannot be played by Bumrah. So Bumrah's machine will be little bit slower. Maybe in 1 minute 3 balls are coming. But Virat's 1 minute, maybe 7 balls are coming. So he is practicing 7 balls in 1 minute. Bumrah is practicing just 3 balls in 1 minute. But both the balls are coming out with the same speed, because they are practicing for his opponent who are bowling at a particular speed. Okay, exactly the same over here. He told that yes, these packets, these photons are coming out. These photons are coming out for the electromagnetic radiation with the speed of light. There is no doubt in that, because they are light. They are coming with the speed of light, but the frequency are different. You already know the concept of frequency. I told you. Suppose now if I count the balls here, I will see in one case the number of balls that is passing is maybe 50. In another case, the number of ball passing is 10. So obviously the one with 50 numbers of ball passing at a particular point will have more frequency. Yes? Agar ज़्यादा frequency होगा, please understand it. If the frequency of the ball is more, obviously its energy will be more, because more number of ball is coming, more energy is coming, and that is why Virat Kohli can play but Bumrah cannot play. Okay? That is what Planck told. Simple. That is what was told by Planck. What he told, that energy of these photons that is coming out, is directly proportional to the frequency of it. Energy of these photons that is coming out is nothing but directly proportional to the frequency. Jitna ज़्यादा frequency है, that much of energy the photon has. Okay, and he equated, obviously he did a lot of experiments, and he equated this equation. He equated it as E is equal to some constant into nu, and he used that constant as, or he gave the term of that constant as H nu. Okay, H is the proportionality constant. And it is known as Planck's constant. Okay, Planck's constant. Fine. And the value of it, you must know the value of it. The Planck's constant value is 6.625 into 10 to the power minus 34 joule second. See why I wrote joule second, you can understand that. Why I wrote joule second, you can understand that. You don't have to remember joule second. See, is equal to, can I write one more term, one more form I am writing, is equal to, can I write H into C by lambda? Can I write it? Just tell me. In place of nu, can I write C by lambda? We can write, right? We had already seen that nu and lambda, what is the relationship? Nu, what is that? H is H, C by lambda. Now about the unit. What is the unit? See, H is equal to, so from here you are doing dimension, I know in physics. So from here, can I write that H is equal to E divided by nu? Can I write it? H is equal to E divided by nu. E is what? Energy. The unit of energy is what? That is nothing but joule. And Unit of nu is what? Unit of nu is second inverse. So joule per second inverse means nothing but joule second. Second will go up. Yes, joule second inverse, joule per second inverse means what? It is nothing but joule second. That is why I wrote over here joule second. And the value of this, as I told you, must know this because we are going to use this a lot. That H is equal to what? This Planck's constant is equal to 6.625 into 10 to the power minus 34 joule second. Okay. Now this particular concept of particle nature, we call it particle nature of electromagnetic radiation. He told them as particles. Okay, he told them as particles, the photons, they're coming out as packets. Okay, this concept of particle nature of the electromagnetic radiation could explain all these phenomena. The photoelectric effect, black body radiation, Compton effect, everything could be explained by this. Okay, now I don't have time today, it's just 2 minutes left. So photoelectric effect is there only in your syllabus. Now what is photoelectric effect? How this photoelectric effect phenomenon could be explained by the Planck's theory? We are going to do this tomorrow. Okay, till then please study this. Books are always there, the link I had already sent. Please study up to the electromagnetic radiation and try to solve some more numericals from the book. Some more are there. Please solve. Solve means what? It's nothing. It's just the interconversion of lambda, nu and nu bar. Okay, just to do that. Then tomorrow we can start with the Planck's theory. Obviously Planck's theory we have done. We can use the application of Planck's theory. Okay. Thank you. Thank you so much.